Okay. So we know there are four kinds of intermolecular forces: dipole-dipole forces, ion-dipole forces, dispersion forces, and the hydrogen bond. So between the sodium and the water, what the intermolecular forces between the cation and the water. So dipole-dipole forces, right? Okay. Ion-dipole forces. Yes or no? Yes. Dispersion forces. Dipole-dipole forces, yes or no? The first one is no. Okay. Ion-dipole forces, yes, because sodium is iron, right? Dispersion forces. We know dispersion forces exist among all molecules. Okay? So there are dispersion forces. There are some individual forces between them. Okay? Hydrogen bond. Sodium has hydrogen bond? No. Yeah. So between the sodium and the water, there are ion-dipole forces and dispersion forces. And of course, between the water molecules, hydrogen bond, yes or no? Between the water molecules, there are hydrogen bond, right?
Yes.
Okay. So this is about the hydration. So all ions, they will be hydrate in water solution. This means they will surround by water molecules. Okay, this example for this substance is no electrolyte. For example, sugar. This is sugar. Sugar is an organic compound. Okay, we know the solid sugar can dissolve in water, right? When it dissolves water, it is just stay in the solution, but it will not dissociate, right? So sugar is no electrolyte because no cations and ions in solution. So this table to show the strong electrolytes and weak electrolytes. Okay, and no electrolyte. No electrolyte. For example, for these organic compounds, they are very stable, right? So in the water solution, they will keep their molecular structure. So there are no electrolyte. And all these are weak acids. So they are weak electrolyte. But this, you can see, they are strong acids or bases. So they have strong electrolyte.
H2O, what's that symbol?
The H2O
Yeah,
is weak.
that's more simple.
Yeah. The pure water is extremely weak. It's a weak electrolyte. Yeah, it's a weak electrolyte. But also, it is a weak electrolyte. It can still kill people. You know.
So strong electrolytes don't give you.
Strong? Of course it is. For example, in water on the ground, okay, just the pure water, you can feel, right? If the electron is the vacuum volt is high, you will die, right? If it's weak, you can feel the electron. But if there are sodium chloride in the water, so that you maybe you will die.
Yeah.
Yeah, because you use the sodium chloride. If sodium chloride, you will die. If no sodium chloride in the water, you may feel uncomfortable, right?
What are you doing?
Okay. Okay, the second part is about the reactions in aqueous solution. So basically, there are 4 kinds of reactions. The first one is precipitation reactions. Second one is acid-base neutralization reactions. And the third one is oxidation reduction reactions. The fourth one is coordination reactions. So here we introduce the first 3 ones. Okay, for the fourth one, we will introduce in another chapter. Okay, so here we just introduce these 3 reactions. Okay, first one, precipitation reactions. So precipitation reactions means the product should be some solid. Okay, in aqueous solution, after the solution, you can find some solid product. So this kind of reactions are called precipitation reactions. For example, for this reaction, okay, so this is a solid. This is a solid. Solid means is not dissolved in water very well. Okay, so you can find the solid product like this. When we add this substance together in water, so you can find some solid, the yellow solid of the product. Okay, so this is called precipitation reactions. So for these reactions, we can use different ways to describe this reaction. The first one is called the molecular equation. Molecular equation means we write all the substances as molecules, using their molecules to describe this reaction. Okay, like this. AQ means in water. Okay, in water. So this reaction happens in water. And we also can use Annelik equation. Annelik equation means, for example, in water, in fact, they are not this molecule, right? So it will change. It will become sodium cation and anion and amine, right? So we can use the Annelik equation. So all this substance in water solution is also become the ions, and this reactant also become ions in water solution. Okay, and for all these are product, you can see the product like this. But in this product, the first one is solid. The solid means is PbI2. Okay, like this. But these 2 substances are ions. So we can also use this Annelik equation to describe this reaction. Okay, and because this is better than this one, right? Because in this equation we can see the two situations of the substances. And we also can use this let Annelik equation. So this means we just remove the ions that don't join the reaction. Okay. For example, in these two sides, there are sodium, right? The sodium doesn't join the reaction. Okay, so only this and this react, form the product. So we can use the Lach-Anick equation to describe this reaction. Okay, and then sodium and then this, they will call them spectate areas. Spectate areas means they just like watch. Okay, it's not like watch the reaction. They don't join the reaction. Okay, so any question for these three equations?
No.
Okay. Yeah, here we can like review.
So fast.
Okay, these three pictures to show this kind of reactions. The first step, we dissolved these two substances, okay, into the solution, into the water solution, and they will be surrounded by the water molecule, right? And then this, and they will form the product, the solid. This is solid, okay, because it doesn't dissolve in water, or it's difficult for them to. They are just very few solid dissolved in water, okay. So we will form the solid. The solid looks like the red, the yellow solid of the product, okay. So here, to show the solubility is the maximum amount of solute that will dissolve in a given quantity of solvent at a specific temperature. For example, sodium chloride. In 100 grams of water, it can dissolve in 36 grams of sodium chloride. Because here, we can say this number is very high. It's very high, 100 of water can dissolve in 36 grams of sodium chloride. And of course, it should be at a certain temperature, at 20 degrees. And we know if we increase the temperature, its solubility will increase or decrease, or keep the same. Increase. Yes, in high temperature, its solubility will increase. So this is why when we dissolve in like some solid, we like to heat, right? To fasten the dissolve. Yeah. I think it's not the reaction. It's because of the physical change. It's not a chemistry change. Because sodium chloride dissolved in and no reaction. Okay. Anyway, so here to show some like compound soluble compounds and insoluble compounds. In solid compounds, it means they have very low solubility. They have very low solubility. Okay. There's still some. This can still have some solubility, but their solubility very small, very low. So we call them insoluble compounds. Insoluble compounds it doesn't mean zero. No, this still but very few. So we call them insoluble compounds. And of course, for the soluble compounds, their solubility is very high. So these pictures to show some examples of insoluble compound. So after the reaction, we can see the solid product. So this kind of reactions are also called precipitation reaction. Okay. So here to show how to write Lach-Anick equations. So basically, first step is write the balanced molecular equation. and then we write the analytical equation. Okay, and then we can cancel the expected atoms, and then we check the charges and numbers of atoms are balanced in the latter analytical equation. So here's the question. Take example. Okay, the question is write the latter analytical equation for the reaction of silver nitrate with sodium chloride. So of course this is a precipitation reaction. Okay, it will give some solid product. So first step, you need to write the molecular equation. Anyone want to try?
Chemistry. Monica.
Monitor.
That is
Monitor.
What?
Yeah, you did chemistry.
No, I did it gym.
You did what?
Egypt.
This one.
He did
Get up,
PCB.
get up, get up.
He's
You know,
chemistry, biology, and physics.
those matter.
Does matter.
I don't know.
With your answers, go ahead.
Juju.
You know that you can go there.
Yeah, he said, you know
That was right.
he said, you know the answer. Does matter. Does matter.
He said, you know the answer. Yeah. So yeah, go there.
Have a try.
Go and try.
Don't be scared, eh?
Yeah, he said, you know
Give
the
the
answer.
answers, go there.
Yeah, so go and try the answer.
Won't believe.
You go cry.
I forgot.
I know, man.
Just tell me the reaction. The reactants.
Oh,
That's good.
So basically, in this reaction, the silver chloride is solid. Okay, the solid product.
Yes.
Now how to write it? How to let analytical reaction.
Okay. Something, my guys.
Yeah, just step by step. You know, first, just write the molecular reaction, the equation, and the silver chloride, chloride is solid.
Let me just let it be. I won't finish.
Good.
Yes.
Yes.
You know, I'm not sure.
So smart.
But then someone will finish.
A week like 7 days.
Okay.
I forgot it.
Silver nitrate, and the reactor is
The direction of the silver nitrate, right?
sodium chloride.
With sodium
Yes.
chloride. So silver nitrate.
Yes, silver nitrate. Good.
Then it's 3 here, right?
Yeah.
Then plus. Is it important to write the state? Its state.
What?
Yeah, just balance you out.
Okay.
Yes,
Okay,
yes,
okay.
but it's what's solution?
And what? Sodium chloride, right?
Yeah.
Sodium what? Chloride.
Yes.
Is that an iron?
And
Then,
equity. Yes, equity.
then it's
By the way,
then
there's
it
no
will
space.
give us.
It's okay. You don't have to write the equity.
So this
Yeah.
one and then it's
Yes.
silver chloride.
Yes. This is solid.
Write smaller things. There's no
Come,
space.
what did you come with?
There's no space.
Like. then
Sodium nitrate. Yes.
Then plus sodium.
Yes.
Tatizo.
Yeah?
Use the other one. We want to see in the video what you are writing.
What you want to see?
Yeah,
So which one should I use?
the other. Just delete first.
The middle one. Let's click the middle X.
This one.
Yeah.
So
Then
small.
click the screen. Just touch the screen. Yeah.
This one. So we said here. It's like silver nitrate, right? Silver nitrate. Said it's in aqueous state.
Okay. Yes.
Aqueous state. Plus then sodium chloride. Sodium chloride. The book is in
Also,
aqueous state.
yes.
Yeah. So to give us then so it will be
Silver chloride.
and silver chloride. It will be silver chloride.
Yeah, this is solid.
Yeah. This one is solid?
Yes, it's solid.
Solid.
It's a solid product.
Okay. Then sodium.
Sodium, yes.
Sodium nitrate.
Nitrate.
Then it will be sodium.
Yeah.
Sodium nitrate.
Yeah, this is
It's
a
in which state?
exactly.
Aqueous.
Yes.
Aqueous state. And
So this is the first step. Is
Yeah, this is the
the
first
molar. Yeah.
then they should finish the
Okay. Second. Who is the second? Yes.
Nice.
Good.
Hey, hey, hey. Each.
What did you do?
Yeah, I don't know how to explain.
I thought it's like a fufu.
It's like a full day.
In the way.
Yes.
Separated.
Lunch, yes.
Or
This is the tacos.
The charge. What is the charge?
charges.
Yeah.
It's a negative.
Yes. No. So another substance.
Oh,
Sodium chloride.
how do I go back?
Dikasih tenso thing.
Hey, man, tell me how to.
Apa?
Then dikasih.
Okay, good.
Where?
Remain.
Click again.
It's okay. Oh,
Then let's click the.
This one? Or it's this one?
Silver chloride is
Try to.
silver chloride is solid.
Ah, okay. Ah,
The other one. The
This
middle one.
one.
No.
and you just select the color
Hey, funny.
The middle one. Yeah.
and the color.
oh, it's
Oh, yes,
already
okay.
there.
Usual.
I think big one.
Yes.
It's AG. Plus.
Is it correct?
Sorry, you keep it.
It's solid.
You don't separate.
Yeah, it's in what solution is solid. It's not ions.
The middle.
Is J. So
Yes.
we don't need sugar.
Then separate that.
And then this one again.
Sodium.
Right.
Yeah, the solid solution.
Okay.
Then you come.
Yeah, good. Just add echo.
So this one.
Yeah, and the, yeah. Cancel. Yeah.
Sodium. Huh.
Give us another one.
Sodium and sodium.
Okay, and then that ionic.
Then therefore you remain with.
So
what
therefore, I'll
left?
remain with this.
Yes.
I don't have any.
Let's write it on top there. There.
So smart. Zambia. Oh, Zambia. Zambia.
Zambia.
And the,
Oh, do I need to
yeah, the charge.
the charge?
Yes.
So it's not
Yes.
Plus.
Plus charge. Silver.
And
Oh, Okay, yes, sorry, okay. And the product, what's the state? Solid. Yes. Yeah, good. Yeah.
Easy.
Okay. So basically,
You see, we helped you.
we know
We got you.
we know for this reaction, the sulfur chloride is solid product. So we write the molar equation firstly, molecular equation firstly, and then we can pick out the ions in the solution, ions, but the product is the solid, and then we offset the ions in both sides, and then finally we get the net ionic reactions. Okay. Okay. Yeah. So the process is like this. This is the molecular equation.
It's only the poor who say.
Okay, and then the ionic equation, and we just offset the ions, and then finally we get the net ionic equation. Okay. Okay, so we can find these kinds of reactions, simple reactions in our life. For example, in the bottom of the boiler, we can find some this solid on the bottom of the boiler. So why there are so many this solids of the bottom of the boiler? Because we know in water there are some, there are very few, right? There are some this cation, and also in water there are some this. This is from the air, you know. The air has some carbon dioxide. When the carbon dioxide dissolved in water, it will form this an ion, and these two will react to give this. So of course, after a long time, like there are very few the cations and ions in the water, but if we we know the boiler, right? The boiler means after several years you can find the solid. So this solid from this reaction. So in this reaction, this is a solid product. This is about the precipitation reaction. Okay. Okay, the second one is about acid-base neutralization reaction. You know, for substances, some are acids, and some are bases. So for acids, they have some they have common properties. We know. So this is acid, right? This is acid. This is also a strong acid. And they can react for the acid. They can react with like metals to form hydrogen gas. They also can react with this and can give the CO2 gas. So actually the acid solution conduct electricity because they are strong acids, so they can release ions. So they are solutions that can conduct electricity. And though some substances are bases, they also have some common properties. And for example, NH3, this is gas, it's a base. And also we know this iron is also a base. It's a base. So how to name the acids and the bases? So basically there are two ways to name the acids and the bases. The first is called aromatase acid. So aromatase acid is a substance that produces proton in water. Okay. And aromatase base is a substance that produces OH in water. So in this way, we can say if the substance can produce hydrogen H cation, is called acid. If it produce OH in water, so it's called base. This is one way to name the acids and the bases. So from here we can say HCl is an acid because it can release the proton, right? The proton its formation is like this. In here we can say this is water, right? And one hydrogen will combine with the water, so form this. So in water solution, in fact, note this. All these are shown like this. So if we release proton or this, so we call it acid. So in this we can say it's acid. And when we say this is base, why? When it is dissolved in solution, it will produce OH. So in this case, we can say this it will get one hydrogen. We get hydrogen to form this cation and release OH. So in all the solutions, the solvent is water. Okay, because in this chapter we introduce the reactions in water. So the water is a solution. It is solvent. The water is a solvent. And in water solvent, it can release OH. So it's a base. So this is the first way to learn acid and base. Okay, just if we release hydrogen. Of course, the hydrogen can come from itself. Okay. For base, it's release this, but this is come from water. Okay. Because all the acids or bases are dissolved in water. So the OH come from water. Okay, this is the first way. This is like a proton in water solution. In water solution, it will be like this. Okay. But we also simply write like H plus. But in fact, it should be H3O plus. Okay. No single H plus in water solution. The H plus definitely will combine with one water molecule to form H3O plus cation. Okay. The second way is called Bronsted acid. So Bronsted acid is a proton donor. It means it can release protons. And the base, Bronsted base is a proton accepted. This means if the substance can release proton, so it's called acid. If it can accept proton, so it's called basis. It's called base. So for example, when we dissolve the NH3 in water, it will happen like this. Okay, so this will give one hydrogen from the oxygen, from the water. The water can also. This is a weak electrolyte. The water can release proton and OH, right? So and the H will combine with NH3 to form the cation. So in this case, we can say NH3 can accept proton, right? So it is base. It's a base. And the water is acid because it can release proton. And so this base and this acid to form this is acid because this guy can release proton. And this is the base. Why? Because it can accept proton. So this is another way to learn the acid and the base. From here, we can see which one is base, which one is acid, which one is acid. Okay. So any question for this? So from this concept, we can learn they are a base or acid.
So that means that was a neutral solution.
Neutral solution. What?
Is it then a neutral solution?
Yes. In neutral, the solution is neutral. It's neutral. It has some cations and also the anions. And the amount, if all of them like +1 charge or -1 charge, so the amount of cations should equal to the amount of anions. So the whole solution is neutral. You know, all the substance, all the system, in my system, it should be neutral. It should be neutral, okay? Okay, here is called monoprotic acids, diprotic acids, triprotic acids. If it only release one proton, it's called monoprotic acid. For example, for this compound, that only release one proton, right? So it's called monoprotic acids. So for this one, it can release 1 and 2, right? So it's called diprotic acid. So for this guy, it can release 3 protons. So it's called triprotic acids. Okay. So have a short break.